We've recently invested in an automatic optical inspection system which will transform and automate how we perform our quality control procedures. Let's see how this works. We start by loading the program that will begin the inspection. These programs are part of an informational database that reflects the unique work that each system undertakes. The machine activates into inspection scan mode. Then the system adjusts the conveyor and gathers information in 2D and 3D with high-resolution cameras, and the findings are cataloged to be used again, with each completed inspection contributing to the data that is collected. Next, a technician views errors in an inspection window. In this instance, defective solder bridging has been flagged. Other errors that can be identified for correction include mis-solder, lifted components, and skewed components. The operator can zoom in and scan closely through the touchscreen. This screen shows a missing component. While this is a map of PCBs identifying the locations and types of errors on the board. This is the programming station, in which techs build catalogs and acceptable tolerance limits in what is found. The boxed areas refer to areas that are already part of the program. No boxes refer to areas that need to be registered within the program. Once board scans are completed and issues are identified and cataloged, the boards return to QC technicians who touch up and correct the boards, send them for another scan, and return them to inventory as subassemblies once cleared. With this technology, a board containing hundreds of components that has just come out of the automated pick-and-place process can be scanned and flagged for errors in under 5 seconds with incredible accuracy. In contrast, visually inspecting the same board takes several minutes, and people aren't as accurate as machines when it comes to finding minute errors.